Without further ado, let's start. And I give the floor to Ingrid Haedrich, Head of Group Degradation Analysis and Modeling PV Modules at Fraunhofer ISE. And she will talk about recent reliability aspects from Fraunhofer's testing and calibration lab. Ingrid, the floor is yours.
Thank you very much. I'm new to Zoom. I will try to share my slides like this. And you might want to tell me if everyone can see the slides. Perfect. Yes, welcome to my presentation about basically news from our testing and calibration laboratory at Fraunhofer ISE. I chose out of many topics, we are discussing 3 topics, which I hope are of interest for you, which is the TOPCon degradation, deviations from the nominal power, so from the label value, and I would like to say a few words about glass quality and glass breakage. This is basically a wrap-up of things which you might have seen at other conferences, but it's always updated to what happened basically in the past month as well. Just a short background, what I'm doing or what we are doing here. So Fraunhofer ISE is a huge research institute in Germany. Within that research institute, we do have testing laboratories and calibration labs. In this case, I'm representing the CalLab PV modules. It is a calibration lab, not just a testing lab. There's a difference. We have at the moment a leading measurement uncertainty of 1.1% for power, PMPP power, and we have experience of 15 years of module measurement. The newest acquisition in the past year in our lab was the WaveLabs flasher, or sun simulator, with whom we are able to measure as well 10 amperovsky solar modules. This is not accredited yet, but we are working together with other panels to bring it over into an accredited laboratory. The other testing lab we have is the test lab for PV modules. There we test modules together with the VDE, which is our certification body, according to 1725 and 6 IEC 61730. Yes, and so this lab also exists for quite a while, and basically the results I'm showing today are coming out of these 2 labs, basically. So, as mentioned before, we have 3 topics I would like to talk about. One is TOPCon, as I've just heard from the wrap-up. It was a lot the topic yesterday already, so I might keep it short and maybe add a few outlooks to it, what we are planning on doing. Then the glass breakage or glass quality topic and the label values. So I'm going to start with a TOPCon. In news over the past 1.5 years, there was always forward, backward, if TOPCon modules are reliable, and some, of course, said they are, and some said they are not. I think, meanwhile, it's accepted that there are UV issues and some moisture issues. In our lab, we developed about 1.5 years ago a test program for TOPCon, where we have basically, we test for PIDD, we do the standard characterization coming out of the norm. We have the sequence B, then thermocycling, then heat, we doubled. So we developed this test program at a time when we didn't have any information on how TOPCon modules would behave. So we just tried to set up something to look for specific things, but also back then we didn't know what the outcome would be. So nowadays we would maybe we know already, okay, it's not so critical to test with this or for that. So we've changed the setup a bit. In total, from nowadays, we have roughly tested around 14 to 15 manufacturers worldwide and different module types. Today, I'm only going to show quickly the results from the moisture testing, so the Dampede 2000 tests, and the results from the sequence B. So as presented by other laboratories as well, we've seen that the TOPCon modules are prone to moisture. We see that glass modules would, in our case, they had an average degradation of more than 1% after a Dampede 1000. Then a little bit more after Dampede 2000, whereas the major degradation factor for the first 1000 hours is the short circuit current. And if you then keep on aging, the fill factor starts to decrease. What was significant for us is that glass modules versus glass backsheet modules behave very differently in the sense that glass backsheet modules showed much worse results in our tests. That said, meanwhile, we have also tested glass backsheet modules which show a better behavior towards Dampede. So it seems to be possible. Then the other thing was the UV aging or sequence B aging. I think this was published, or some of you might have seen it, in this sequence where you have an initial measurement, then we have a Dampede 200 and a UV 60 step, then a humidity freeze step, then another UV 60 and another humidity freeze step. We observed a certain W pattern, as we call it. So we see a strong decrease after UV, then a recovery in HF, another degradation in UV 60, and another recovery. We don't see it like, it's not that all modules behave with a strong W pattern. Some have it less, as you can see, and some have it more. We know that the degradation comes from is mainly observed in the short circuit current, open circuit voltage, and of course our recent investigations, and we will soon publish results on that, is to understand the recovery, because what we want to simulate in our testing lab is the behavior outdoor. And outdoor, you would have all of it together. So you would have UV irradiance, but also moisture. And so we do a lot at the moment to separate the recovery, because in an HF and in humidity freeze chamber, you would have, it's dark in there. You have moisture, you have temperature influences. And I think it's already known that a recovery happens quickly with light. But then the question is, how far does the recovery go? And so we are currently investigating that a lot to understand that recovery, to really look what happens in the field. Here, I also would like to mention that we are looking for partners, or more partners to run experiments on that. So basically, the idea is that we would like to pre-age modules in our testing labs and then expose them in the field and compare it to modules which are not pre-aged in the lab, and then compare it and understand the actual auto behavior of these modules in the best way, and then with the aim to test it accordingly better in our indoor labs. So the next topic I'd like to talk about is the glass breakage. Here also there was a lot of reports coming from that there was class breakage seen in the field. Also in our institute, we had an increasing number of inquiries concerning class breakage. Also, we figured that they are happening for framed and unframed modules, that it's more about modules which are larger than 2 meters square, and that it started with a trend towards thinner class, and therefore we started to look into that phenomena and try to understand it a bit more. What was very surprising for us is that the class breakage happened in the field only after a few months. So not after a long time. It was just after a few months that people came to us and asked, like, look, this is happening. What's going on? So here we started to look into class quality. We saw the trends. So trends went to class thicknesses which are below 2 millimeter. At the same time, the module area increased above 3 meters square, and there was an assumption that this might be caused by the pre-stressing of the glass. So we chose this specific aspect and looked into that in a first step. So with simple scalp measurements is a polarization, polarized scope optical measurement device to determine the pre-stress of glass. We simply compared the values given by the glass manufacturer or how it was specified for the glass, which you see on the x-axis here, and then we measured it ourselves. And here we found that the pre-stressing was effectively better than even higher than it was given by the manufacturer. So, for example, if the manufacturer would say the pre-stress is 50 megapascal, we measured more than 60 in average over the class types we've gotten. So, and the same if they said 80 megapascal, we measured even more than 90. So that's good for news, I think, for glass manufacturers. Then we went towards modules, so laminates basically. And here we compared in a small study. It's always difficult to run mechanical load testing because you basically destroy in a long-running test one module, and so you need a lot of modules which you then destroy, and they should have the same dimension and the same framing that it's comparable. So that wasn't easy, but we managed to get in a study 4 module types with similar sizes, but with varying glass thicknesses. So we had a module type with 2 millimeter glass, then a module type 1.6 and 1.6 millimeter, and another one with glass module with 1.6 millimeter front back. And as a reference, we chose a glass backsheet module with a front glass thickness of 3.2 millimeter. And here in that first study, we saw that the failure loads were the lowest for the 2 millimeter glass, so not for the 1.6 millimeter glass, but for the 2 millimeter glass type. And we could see also a correlation that with increased stress on the glass surface, the failure loads, also like the moment when the module breaks, is later or is increased. Yes, so we do know that, or we could prove that the glass surface stress has an impact on the mechanical load behavior. At the moment, we are trying to run more and more tests, and there's more and more published, which you can find in this publication here if you scan the code. At the moment, we are working on inhomogeneous loads. So we are proud to announce that we have now the first worldwide, to my knowledge, test stand where we can apply inhomogeneous loads to a module. This is important because what we actually see outdoors, like the wind loads and the turbulences behind the module, modules never just see only homogeneous load. They might get on the top a pressure, and underneath there is a turbulence. So you actually have you pull the module, and so we try to run tests at the moment with different inhomogeneous loads. And another motivation for that is also that the breakage patterns which we see in the field from customers, we cannot yet reproduce them in our lab. So when we break the modules in our lab, we usually get slightly different breakage patterns than what we see outdoors. And we try to understand where that comes from. And of course, our duty is also to get better in simulating whatever happens outdoors. And so there's the inhomogeneous load. And the other thing which we are building up at the moment, or we have it already, is that we can break modules under different temperatures. So we want to cool the modules down to -20, -40 degrees, and then apply load, and then compare the breakage patterns of the glass. Yes, so the third topic I'd like to quickly talk about is the label value. So usually there is, like, as you probably all know, there is a manufacturer, and the manufacturer gives modules out of the manufacturer line, modules to a test lab. The test lab measures the module and gives back the so-called gold module. And based on that gold module, the manufacturer then adjusts his line flasher and then labels accordingly all the modules which the manufacturer produces, and that's then the label value which you would give to the installer. What we have found in over the past 15 years, being a calibration lab, is that there is a trend. So if we measure modules in our calibration lab, coming from all over the world, and we had in total, I think, 60,000 measurements here over the past 15 years, and we filtered them accordingly. There's I don't want to go into details how we filtered them, but in the end, we try to exclude manufacturers which use us as a reference module, so where we basically give them the golden module, and we also filter just for the top 14 manufacturers in the world. And with that advanced filter, we had still 954 measurements which we could analyze. And here the result was that we see a decrease of approximately 2% in deviation from the nominal power from the label value of 2%, and an average deviation last year of 1.3%. We just recently got the next measurement point from 2024, and I can already say it's a little bit better than 1.3%. So there seems to be an upwards trend now. Yeah, but still, it's for us a concerning issue that basically almost all modules which you measured last year had less power than set on the label, and that was different a few years ago. What we would like to do as a calibration lab, we want to create awareness. I think big EPCs, they usually do the effort, and they come to testing labs, or they cross-check the label value. Small installers can't do that. It's just simply too expensive. Yeah, so therefore we would like to raise awareness and go also in a dialogue with other testing labs where the deviation might be caused from. We have our own ideas where the deviation could be coming from. Yeah. Just to a few words to our own calibration lab. So we are running a round robin for many years already, where we basically together with these, like you're looking to the left side here, where we compare ourselves to NREL, to SD, to ISE, and that's an interesting round robin because all of these testing laboratories have different bodies, metrology bodies they are referencing to, and still we manage to have around or less than 1% deviation to each other, which is, I think, quite very good. I think the next round robin, so this data is already 2 years old. I think a new round robin is planned. And also, I would like to show that we are comparing ourselves also to our body, which is the PTB, and here we have a deviation to the PTB calibrated value of less than 1%. And we are very happy about these results. And I think the last measurement point is not even in. So 2024, we had 0.3 deviation from the PTB calibrated value. With this, I'd like to thank you for your attention, and I'm happy to answer questions.
Thanks, Ingrid. That was very insightful. I think there's a lot of questions on the chat. Could you please answer the chat in written form there, and then we will touch upon some of the topics you mentioned during the panel later.